In this circuit, auto intensity control of street lights, we have used a number of white LEDs for the street light purpose. Usually this street light uses headlamp, high intensity discharge lamps, for example, sodium vapor lamps, mercury vapor lamp and metal alloyed lamps, which have difficulty in starting time, whereas switching over to LEDs could be much better in the sense it switches on instantaneously. And it is also can have dimming facilities. For this purpose what we have taken, we are taken a microcontroller and a number of LEDs, in series and parallel combination. For example, there are 4 LEDs here and there are 8 such, so 8 into 4 what we say, and again in this branch, and this branch, all of them are met parallel, so about 96 LEDs, 32 and 32 LEDs, for each in series. That means one LED is about 2.5 volt for as the white LED concern, and its 2.5 into 4 is about 10 volt into a supply is about 12 volt. About we need to drop certain voltage which is dropped by this resistor, and we have a MOSFET switch here. This MOSFET switches on the LED for this positive flow this way, and the finally passes through this resistor and then the switch. There is one typical arrangement made here, in the sense what we have is, we have one transistor here, which is driven from the output of the microcontroller, and when the microcontroller output goes high, that means this point goes to low, this inverting operation. When this goes high, this collector goes low. This collector is connected to gate of the MOSFET, so the MOSFET doesn't get any drive. Once the MOSFET doesn't get the drive, no current flows through this, because this is a switch. This arrangement has when done is, because the voltage it is available from the microcontroller output, it may not be sufficient enough to drive the MOSFET. So what in fact we do, since it get hardly about 3 to 4 volt at the output port which is switching on this transistor, and that time this MOSFET goes off, because this point goes to ground, and while this is off, it gets directly the 12 volt here. So in the ratio 1k is to 10k at cross 12 volt the potential divider, we get round 10 to 11 volt here, so the MOSFET would be faithfully switched on. That is the reason why this arrangement has been made. We could have greatly connected this point to the MOSFET gate, so that when this is high this switch would be on, but that perhaps would be not a very reliable switching operation, and when this point goes low at in transistor switches off. One time switch of this point is now divided in the ratio 1 is to 12 is 1 is to 10, because 12 volt that is being fed here. We get roughly about 10 to 11 volt which is available at the gate to source, and this behave as a switch. And that time it's closest, that means when this is delivering low logic the LED is on, when this is delivering high logic the LED is off. So depending on the requirement the duty cycle is so given here for changing the intensity of the lamp, the LEDs. The other advantages we have here is that the program is so made that the in theoretical time interval, this light will be slowly going with less and lesser intensity starting from the full intensity. For example, if the duties say 10% here, then this LED is glow to the extent of 90% when their duty cycle is 90%. Here the LED is glow with the 10% duty cycle. That means 10% intensity, and that is how, and this timing is so made that after night at 10 o'clock or 11 o'clock, if somebody wants the lighting to be progressively reducing, this will be progressively reducing from night 11 o'clock till the morning, and after the morning it switches off. and again in the evening it switches on. This is how the program is made. The other connections are standard, like for example a power supply, which has been separately said, and this standard connections of the microcontroller, for example the reset, the crystal, and these are separately discussed.